In this video, I'm going to be talking about derivative rules. First one is the power rule. So when you take the derivative of a certain value, what it would be, say, x raised to a certain value n, this would equal n times x raised to n minus 1. So say we're taking the derivative of 5x raised to the 5th power. What you would do is multiply the exponent to the factor and then subtract the exponent value by 1. So that's what this is saying right here. So for 5x raised to the 5th power, you would multiply 5 to 5, get 25 minus the exponent by 1. So it'd be 25x raised to the 4th power. When you take the derivative of a constant, it will always be 0. Say you were trying to find the derivative of 5. When you look at 5 on the grid, just a certain point 5, it will be a horizontal line, and the slope of that is 0. The exponential rule will say that if you have a certain value raised to x, then a of x times the natural log times the value that is being raised. So say you're doing 5 raised to x, simply will just be 5 raised to x times natural log times the value 5. You can also take derivatives of trig functions. The derivative of sine x equals cosine x. The derivative of cosine x equals negative sine x. Here's an example of a function equals 2 cosine x minus 4 sine x plus 5. So f prime, or the derivative of the function, equals negative 2 sine x minus 4 cosine x. See how these flip right here. So say you plugged in the value pi over 4, you'd put that into wherever you see the x's. So it'll be negative 2 sine times pi over 4 minus 4 times cosine times pi over 4. So then you'd find the values of pi over 4, sine pi over 4, and cosine pi over 4. Multiply those by what they're being multiplied to. So it'd be negative 2 times radical 2 over 2 minus 4 times radical 2 over 2. After some math, you'd get negative 3 times radical 2. This one's called the sum difference rule. So you're taking the derivative of two numbers or two functions being added together. You'd simply just take the derivative of the first function plus the derivative of the second function. So you got the derivative of 5x squared plus 4x cubed. Take the derivative of both of those, you'd get 10x plus 12x squared. Simply what it would be. Now we got the product rule, which is taking the derivative to two functions being multiplied to each other. So this would be the formula f prime of x times g of x plus g prime of x times f of x. Here's a quick example of that. So you got h of x equals x cubed times x squared plus 4. You would lay it out how this formula is written. So you got 3x squared times x squared plus 4 plus 2x times x cubed. After some math, we got 3x to the 4th power plus 12x squared plus 2x to the 4th power. So it'd equal 5x to the 4th power plus 12x squared factor x squared times 5x squared plus 12. This one is the quotient rule. So you got one function divided by another function. So this would be the formula. It'd be f prime times g minus f times g prime all over g squared. So, for example, we got 4x minus 1 over x squared plus 2. So, let's start with the denominator. You go x squared, which is this function g, I wrote it a little weird, times the numerator, the derivative of the numerator, which would be 4, minus the original function 4x minus 1 times the derivative of denominator, all over the denominator of this function squared. So then, after some math, you'd get 4x squared plus 8 minus 8x squared minus 2x all over x squared plus 2 squared. And after subtracting, you would get 4x squared plus 2x plus 8 over x squared plus 2, all that is squared. The last one we got is the chain rule. So that's when you're taking the derivative of a function within a function. So you got the derivative of the first function times the inside function, and then the inside function, the derivative of that one. So for instance, you got x squared plus 1 cubed, all of that being cubed. The inside function would be x cubed plus 1, and then the outside function would be x cubed. So when you take the derivative of x cubed, that would be 3x squared, but you're multiplying that by the original function still, times the derivative of the inside function, which is 2x. Multiply that, you would get 6x times x squared plus 1 squared.